With that, it's my pleasure to introduce Goggy Davidowitz, I hope I pronounced that right, professor of entomology at the University of Arizona and an expert in entomophagy.
Doesn't come off? Okay, I can't stand in one place, so. And clearly I can't give a talk either. Okay, so I'm going to talk about using insects as a way to address the 9 billion problem that were effectively the reason we're here today. And I'm saying address and not solve because it won't solve it. Nobody's going to give up steaks. So this is the problem we're all familiar with. Is by about the year 2050, there'll be more than 9 billion people on the planet. And the question is, how do we feed that many people? So the problem arises from math, really. If you look at food production increase over time, it increases incrementally. It follows an arithmetic progression. But population growth is geometric. It's an exponential growth. And so we're right over here with about a little over 7 billion people on the planet. But in 2050, we're going to reach this tipping point where we'll no longer be able to produce more food than there are people on the planet. And this is going to happen in our lifetime. So the students that are out here, when you're in your 50s, the planet won't be able to sustain its population. Not that I want to be depressive about it, but that's very sobering. The Food and Agriculture Organization, United Nations, estimated that we need to increase food production 50 to 70% in order to meet this many people. And as Timothy explained to us, that's not going to happen. We know that's not going to happen. So the question is, what do we do? And that's why we're here today. So one potential is using insects as an alternate source of protein. So first off, 80% of the countries in the world, that's about 180 countries, 176 countries, today eat insects as part of their daily diet. That's about 2.5 billion people. It's about a third of the world population. And they consume something like 1,600 species of insect. And these are just from pictures from markets in Asia. So a lot of people already consume insects. And the issue is, but that's typically sub-Saharan Africa and Asia and not in the Western world. The problem with this, which is fine, but the problem is that over 90% of this are harvested from the wild. And that, as you can imagine, when you're taking insects out of an ecological system, the cascade of events that happen in the ecosystem is not good. So in 2013, the Food and Agriculture Organization of the UN came out with this report called Edible Insects: Future Prospects for Food and Feed Security. This fell on, so it was 5 years ago. This fell on really receptive ears. In the first week alone, it was downloaded 1.5 million times. Since 2013, since this came out, well, I'll actually show you. This is what I pulled off of Web of Science. This is just number of publications about edible insects and entomophagy. And you can see it's kind of low numbers. This is 2013 when the report came out. And so 2/3 of all publications on edible insects came out in the last 5 years. This is a big, big movement towards edible insects. In the last 5 years, there's now 230 startup companies in the Western world working on edible insect. There's about a little less than 30 in the United States. Supply can't meet demand. It's a big deal. So why insects? And by the way, does everybody know what they ate for lunch? So why insects? There was a little hesitancy there in that response. So there's two big reasons. One is nutrition and the other is sustainability. So nutrition, and I'll just give you some numbers in the next couple of slides. There's issues of digestibility, protein, fats, minerals, fiber, and sustainability. Sustainability in terms of water, feed, the amount of land, and greenhouse gases. So I'm just going to start with nutrition, so I'll move over to this side. So a cow, 40%, you can eat and digest only 40% of a cow. The rest is hide, bones, intestines, and stuff like that. You can eat 100% of a grasshopper. You can digest 80% of it. The other 20%, I have to do the math real quick, the other 20% of it is fiber. It's the exoskeleton. So it's good for you anyway. So that's the digestibility. Here's the nutritional content of it. So if you're looking at proteins, for example, this is in a 200-calorie serving. Crickets, you can produce 31 grams of protein. Lean beef, 22 grams, and salmon, 20 grams. So there's more protein in insects than there are in vertebrate livestock. Fats, insects have less fat than vertebrate livestock, and the fats that they have, insects have almost no saturated fatty acids. They have a little bit in cell membranes, but it's mostly mono and polyunsaturated fatty acids. Omega-3s, omega-6s, the good stuff. Actually, here's omega-3s, and you can see crickets have a lot more than beef, less than salmon, and of course they have fiber that vertebrate livestock don't. If you're comparing crickets to chickens, I know you can't read the numbers here, just look at the size of the circles. In terms of protein, crickets have more protein than chickens, more calcium, more potassium, more iron, and more zinc. So they're healthy in terms of the micronutrients, the minerals. This is again comparing a grasshopper to cattle. So a cow is about 50-50 protein and fat. 72% of a grasshopper is protein, and only about 16% fat. But again, those are the good fats. In terms of protein, other nutritional components to this, they're about equal in terms of protein. Insects have less fat, a lot more calcium, and more iron compared to beef. So what about the sustainability aspect of it? So here we're looking at what is the cost, how much can you produce with 100 gallons of water? So that's 100 gallons of water. You can produce 6 grams of beef, 13 grams of corn, 19 of chicken, 63 of soy, and 71 of crickets. So insects are very efficient at producing, water efficient in producing protein. They're also very efficient in converting feed into food. So for 10 kilograms of feed, which is about 22 pounds, you can produce 2 pounds of protein from beef, which is about a 10% conversion efficiency, versus 20 pounds from a grasshopper. That's about 90%. If we're looking at sustainability in terms of land use, so this is land, all the land used for cow pasturage, that's this. These smaller ones are sheep, horses, and sheep and horses. This is livestock feed. So in order to feed these cows, you need this much land to produce cattle. And how does that compare to insects? Well, this is beef, so you need 200 square meters of arable land to produce 1 kilogram of beef, 50 square meters to produce a kilogram of pork, 45 to produce a kilogram of chicken, and only about 15 to produce a cricket. So in terms of land use, insects are a lot more sustainable than vertebrate livestock. And what's really cool about this is you can grow cattle only on a monolayer, right? It's one cow on a piece of land. You can't stack them up. Insects are very amenable to vertical farming. So this is just example. This is in Holland. These two are in Holland. We use, in my lab, we have 12 layers. So it's very amenable to vertical farming, which means it's very amenable to urban farming. And in fact, most of the companies that grow insects are actually grown in urban environments, in abandoned warehouses, people's garages, things like that. And in fact, they're selling these kits. These are for mealworms. You can buy these for about $130. They sit on your countertop. You put the leftover foods from lunch, from breakfast, or whatever, pancakes, toast, I don't know, whatever you have. You put them in there. You start from the top and you work your way down. And after a number of months, you have crickets that you throw into the wok and stir fry and have with dinner. So these are household countertop insect production facilities. Another point of sustainability is the feed. I mentioned before that they're more, the conversion efficiency of insects is very high. But as we've talked about, and Andy talked about this, something like 40–50% of the food that we produce in the United States gets thrown out. It gets thrown out into the landfill. That's food for bugs. Insects, a lot of insects are detritivores. They eat decaying organic material. So this is gold. Insects are very amenable for food waste, agricultural waste. This is work that we're doing in my lab. These are mealworms. These are pupae of the mealworms. Here are the mealworms themselves. This is agricultural waste that we've gotten from organic farmers. We've shredded it, we've dried it, we processed it, and we give it to the mealworms. And we're trying to do this in mass numbers. Our biggest issue is getting a good supply chain of food waste. Oh, and insects, this is a completely different kind of waste. Mealworms eat styrofoam. So there's actually two companies, one in China and one in Holland, that are looking into using mealworms and waxworms to decompose styrofoam and plastic. So we actually, in my lab, we have a box full of styrofoam, and in March, we're starting an experiment to see how efficient they are in converting styrofoam. And that's pure styrofoam. They go all the way through adulthood and are reproductive pure styrofoam. It's because of the gut microbiome. So to kind of summarize the sustainability thing, if insects are more edible, need less water, use less feed, and emit fewer greenhouse gases than beef. Remember again, 40% of a cow you can eat, 100% of a grasshopper, but 80% of it you can digest. And to answer the question that was in the before, for about 20,000 liters of water for 1 kilogram of beef, you need about 8 for a grasshopper. In the question, in the poll, it was for a cricket, and they're more efficient than the grasshoppers. So it was 22,000 to 1. Feed, they're a lot more efficient. Insects are a lot more efficient converting feed, and again, they produce fewer greenhouse gases. Just to make this a little bit humorous, so let's look at it this way. You have a male and a female cow. The male and the female cow do what they do. They produce a baby cow. After 22 weeks, you take these 3 cows, you do it, you process them, you produce about 1,170 kilograms of meat, which is the meat consumption of 15 people for over a year. That's cool. Now let's take 2 grasshoppers. Assuming no mortality and stuff like that, after 22 weeks, this male and female grasshopper will produce 3,725,290,000,000, you get the idea, grasshoppers, which is 890 million kilograms of meat relative to 1,100, which is enough to feed the whole country of Belgium for over a year. So, I mean, I know this is just math, and it's, you know, things die along the way, but the idea is kind of clear. The protein production from insects is a viable, sustainable way of addressing the 9 billion people issue. What about the market? So this is just in the United States. The histogram here is just in the United States. We're over here. It's about a $10 million market. This is insects for food. For feed, it's much larger than this. So this is mostly flour, protein bars, snacks, and others. So it's about $10 million. But 5 years from now, it'll be in the order of $50 million. Worldwide, the market projections are in 2017 were 55 for food, $55 million for food, and $900 million for feed. In just 5 years, it'll go from 55 to $733 million for food and over $1 billion for feed. So it's a huge industry. In the United States, the 25 so companies cannot meet demand. We're getting orders from food companies and so on that want thousands of pounds of, we can't produce it. We're close, but we're not. The biggest issue is mass production. So there's, we're eating insects. It's like sushi 40 years ago. Nobody in the United States would eat raw fish. It was considered disgusting. How many sushi restaurants do you guys have in Riverside right now? And that's where, what? At least a dozen. And that's where we are with the insects. There's the so-called yuck factor. I personally don't think it's a big deal. There are newspaper articles or articles on websites and so on daily at this point on edible insects. So I really don't think that's going to be a big issue. And as I said, 230 companies will not invest money if there was no money to be made in this. Okay, so so this whole industry in the Western world started 5 years ago when that FAO report came out in 2013. What don't we know? Well, right now, almost everybody grows what we call the big three. Those are crickets, mealworms, and black soldier fly larvae. And the question is, are the big three the three best? The reason we grow these, or the companies grow these, I don't, but the reason companies grow these they've been a mainstay of the pet and fishing industry for decades, since World War II. And so we know how to grow mealworms, we know how to grow crickets, we know how to grow black soldier flies. So everybody's doing it because it's a really low-hanging fruit. But the question is, are they the best ones we can use? The approach I'm taking is not to use these, but to use different insects for different feeds. Anybody who knows anything about entomology, there is some bug out there that will eat something you don't want it to eat. We need to learn mass rearing protocols, insect health, nutrition, and processing. And just to kind of sum this up, farming insects as food and feed, they're highly nutritious, sustainable. It's a promising new industry, but it's a new industry, and we still have a lot to learn to make it work. And I think that's it.